Good morning, guys. We're going to go over our Unit 1 summary sheet so that you guys can be ready to study for our unit test. So these are basically the goals that we've learned for our first unit, and I'm just going to solve them as I would if I were live and in person with you. So it says for every blank flags, there are blank stars. So we started off working with ratio language and how to use ratio language to make a comparison. So I can tell from my picture that for every 2 flags, there are 100 stars. I know that there's 50 on each flag because it's an American flag. I'm not going to count them. The ratio of stars to flags is 100 to 2. And I want to point out that I did stars first and then flags. So it was 100 stars to 2 flags, and the order matters. If you said the order of stars to flags was 2 to 100, that would be wrong. Then moving on to using rate language. Rate is a comparison for every 1 flag, especially when we're talking about unit rate. We're always making a comparison to 1 unit. For every 1 flag, there are 50 stars, and there are 50 stars per flag. That word per is a key word for comparing things to 1. When you hear per flag or per mile or per gallon, they're talking about a comparison using 1 flag or 1 mile or 1 gallon. You also want to watch out for words like each or every one. They're also keywords for finding unit rate. And our other key level goal was goal 3, to use integers to describe real life situations. So we did a couple of activities where we read situations in real life and decided whether that would be a positive integer or a negative integer, focusing on the keywords in the problem. The first situation says the Eagles gained 7 yards on the last play. Gained is our keyword. Gain would indicate a positive integer, so I would circle choice A. And then the second choice says the temperature has decreased 10 degrees in the last 12 hours. Decreased is our keyword, and decreased decreased shows a negative integer. All right. Way back in the beginning of the year, we started off talking about distributive property. And this doesn't really go in with this unit, but it is an important skill to have for 6th grade and beyond. So when we talk about the distributive property, a lot of times we related it to finding the area of a rectangle. And we said that there were 2 ways that you could do that. You could, number 1, you could distribute the 5 to each one of these numbers and find the area of each piece of our rectangle. So I could do 5 times 7 and then 5 times 3 and then add those 2 parts together, which would be 35 and 15, and 35 and 15 would be 50. So the area of my rectangle is 50. Or my second way would be to add the length of this side together and then multiply it by 5, my factor on the side. So I could do 7 plus 3 and then multiply that by 5. In that case, I would do 7 plus 3 is 10, and 10 times 5 is 50. The important thing to remember is that these are equivalent expressions. They get you the same answer either way. Even though they're not written the same way, they do give you the same answer, and that's how the distributive property works. Okay, back at goal 6, we started writing fractions as percents, or writing a rate as a percent. So our first situation was 7 out of 10 kids in the class are girls. What percent are girls? So 7 out of 10. So I'm talking about the part out of the total class. That's 7 girls out of 10 in the whole class. And when we're talking about a percent is always a number out of 100. So I'm going to change that into a number out of 100. So I know that to scale this up using my ratio thinking, I would have to multiply 10 times 10 to get to 100. If I'm making the whole class 10 times bigger, I also need to make the number of girls 10 times bigger. So that would be 70. So 70% of the class would be girls if there were 7 out of 10 kids that were girls. Then the second question says James got 18 out of 20 correct on his last quiz. What percent did he get correct? So again, we're starting out with a part to whole or a part to total relationship. The part that he got right was 18. The total possible right on the test was 20. And that means that if we're going to scale that up to a percent out of number out of 100, we're going to have to multiply by 5. Because 20 times 5 is 100. If I'm making my total points 5 times bigger, I also need to make the number right 5 times bigger. And 18 times 5 is 90. That means James got 90% of his questions correct. For goal 6, we talked about numbers on a number line. We talked about mixed numbers, fractions, and integers, positive and negative numbers, and their proper place on a number line. One thing we talked about was opposite numbers. Opposite numbers are just the same number with a different sign. So one would be positive and one would be negative. The important thing to remember about opposite numbers is that they are equally distant from 0 in opposite directions. So if I was going to choose opposite numbers, I could choose maybe 2 and -2. So if I were going to put that on the number line, this would be +1, this would be -1. And if I'm going to make them equally distant, then 2 would be here, +2, and -2. So my +2 and my -2 would be opposites, and my +1 and my -1 would be opposites. And then we got more specific, and we talked about specific points on our number line. And we're going to give each one of these points, A, B, C, and D, a mixed number. Looks like A is a negative number line. My negative number line is going from -7 to -9. So it's just a small piece of the number line. Each unit is further broken down into fractional parts. It looks like these units are broken down into 1, 2, 3, 4, 5, 6 equal parts. So I know that my fraction is going to be represented by 6ths. So I know that point D is -7 and 1/2/6. I know that point C is -7 and 1/2/3/4/6. Point B is -7 and 1/2/3/4/5/6. And point A is past 8, so it's going to be 8 and something. It's going to be 8 and 1/6. -8 and 1/6. And our other number line is a positive number line. The positive number line goes from +5 to +7. So moving in a positive direction, we're going to be moving from left to right and identifying our points on our number line. It looks like our units are again further divided. I'm going to check out how these are divided. 1, 2, 3, 4, 5, oh, 6 again. Should have chosen something different. So each unit is further divided into 6 parts. So this is +5 and 2/6. D is +5 and 5/6. 1, 2, 3, 4, 5. B is 6 and 1/6. And A is 6 and 1, 2, 3/6. Or we could call that one 6 and a half, because 3 out of 6 is 1/2. All right, goal 8 was to be able to interpret inequalities. So we're going to use the greater than or less than sign to tell the difference or tell which integer is bigger. Remember, when comparing negative integers, the closer to 0 you are, or the closer to the positive side of the number line, the bigger you are. Remember the saying that everything is opposite in negative land. So numbers that would be larger when they're positive are actually smaller when they're negative. It's the opposite. So in -7 versus -10, -7 is closer to 0. It's more positive. So -7 is actually greater than -10. When we're comparing a positive versus a negative, positive is always better. Positive is having something is better than not having something. So +8 is greater than -2. Again, we have another positive versus negative over here, even though this seems really weird because we're used to 100 being a very big number and 2 being a small number. This is -100 and this is +2. So +2 is more than -100. And these two are very, very close together. We have -50 and -50 and 1/2. -50 is closer to 0 than 50 and 1/2, because as the numbers are getting larger or increasing on our number line, we're moving to the left, which is further away from 0. So this is our larger number right here. And in class, everybody got that right away, so I don't expect there to be problems with that one. Moving on to number 9, solving problems using unit rate. So thinking back to our first page where we talked about rate language, where we were finding out for every one thing. That would be unit rate. And these problems, you have to find unit rate before you can solve the problem. So I chose these for a reason, because they kind of cover 2 goals. Can you find the unit rate? And then can you solve the problem? So again, we're going to start off thinking about comparing. Caden's office recycled a total of 27 kilograms of paper over 3 weeks. So in this problem, we're talking about kilograms and weeks. What I know is that 27 kilograms can be recycled in 3 weeks. What I want to know is after how many weeks will Caden's office recycle 18 kilograms. Now I'm leaving my space in between here because I know that I cannot do 27 divided by something to get me 18. 18 is not a factor of 27. So this is not going to be a one-step problem. I'm going to need to find something in between here to help me out. I'm also going to use my calculator to help me out because the goal is ratio, not division. So this is where my unit rate is going to help me. So I want to know how long would it take to recycle just 1 kilogram. So the first thing I'm going to do is I'm going to scale this down to a unit rate of 1 by dividing by 27. 27 divided by 27 gives me 1. That means I also have to divide 3 by 27, which I'm going to use my calculator for. As soon as I find it, here it is. So I'm going to do 3 divided by 27. And that's going to get me a really small number. I'm going to round it off and say 0.11 or 11 hundredths. And now I want to scale that number back up to 18. So to get from 1 to 18, I can just multiply by 18. And I'm also going to multiply my 11 hundredths by 18. Which is going to give me 1 98 hundredths. It's about 2